Hi, in the following presentation about the Service Unit Terminological Services, or SU-TermServ, I'll introduce the NPM package infrastructure and our distribution strategy. My name is Wiedekopf, and I'm a researcher at our site in Lübeck. If you have any questions about the SU-TermServ, please refer to our website, mri-termserv.de, or reach out to us via email at team@mail.mri-termserv.de or the MRI Zulip chat. The slides for this presentation are also available on our website. The origins of the Service Unit Terminological Services lie within the HIMED consortium, and we have provided the central terminology server for HIMED until 2023. That server then became the central server for the Medical Informatics Initiative and the Network University Medicine. However, resources were uploaded in an ad hoc fashion, so the resources that were available on that server have evolved organically over time, or historisch gewachsen in German, with all the negative connotations of that expression. Consumers of the service had no high-level overview about the content of the server, and on a low level, we didn't have any information about the responsibilities for resources, their provenance, that is where resources come from and who generated them, and so forth anymore. This led to a need for a new strategy combined with a redeployment from scratch, which we then completed in 2024. Our new strategy centers around the use of higher NPM packages, which I will explain shortly. All resources, without exception, will be uploaded from NPM packages. Packages will declare dependencies, and common terminology will be packaged independently. Rigid quality control processes will be instituted so that we can ensure that all resources that are needed by downstream packages are available and functional. We do not limit our scope to the resources needed for implementation of the MRI's core dataset, and users can request the upload of resources that are used in other projects. As a side effect, the setup allows for a deterministic server setup, so that we are more agile in case of disasters, and local instances, such as in the data integration centers, can be set up using the same distribution of resources. Also, as our package pipeline is based on public Git repositories, there is full transparency for resource changes. Using NPM packages also opens up exciting opportunities with regards to tooling, which I'll touch on at the end of my talk. Let me talk a bit about NPM packages. Node packages are a fantastic mechanism that has become part of the standard as of FHIR R5. The concept originates from the broader internet, so it's a great example on how FHIR has taken elements of established standards and de facto standards to reach its goals. The whole concept is in very broad use both within the greater FHIR community and also the MRI and NUM. Indeed, it is now the primary format for distribution of the MRI's core dataset, or CDS. Packages are uploaded to searchable registries and can be referenced and downloaded by all consumers. In the FHIR world, there are standard registries, with the product Simplifier having seen broad adoption, but can essentially be hosted anywhere. On the right side of the screen, I've shown an example package, in this case from the 2024 version of the core dataset module Person. The NPM package has a rather simple structure, and it is distributed as a compressed tarball. I've highlighted some resources. In blue, there is metadata for the package itself, while terminological resources are highlighted in green. Profiles are shown in dark gray. Since we provide a terminology server, they are not as important to us as the terminological resources. You'll notice also that the two green code system resources on the bottom are something that doesn't really belong in this package. Those resources are instances of the ICD-10 WHO code system, which is used in Germany for mortality coding. In our new strategy, this resource will be pulled out of the dependent package, and we declare a dependency on the ICD-10 WHO package instead. Package dependencies form a directed graph, and it's very important that this graph is consistent in terms of versions that are available. Those dependencies are declared in the package manifest, that is the package.json file. Let's look at that file in more detail. So this is a package.json of the same package as before. This is the original package from the Simplifier registry. Notice the relative lack of dependencies, shown in green. Dependencies are transitive, which looks like this. So when a package from the core dataset depends on a package, for example, the base profiles defined by HSF in Germany, and that package depends on a package from the KBV, which then depends on another package from the KBV, and so on, they're implicit and explicit dependencies. We have focused on these dependencies. You will, for example, not find a package-level dependency to SUMCT in the core dataset package, or anywhere down the chain. We also try to be as explicit as possible. When we have identified a package-level dependency, it's never a bad idea to explicitly declare that, rather than relying on these implicit transitive dependencies. We have also, as you can see by the greater equals and caret expressions I've highlighted in blue, assured that we remain flexible with the declared dependencies so that technical corrections on our end can be done as needed. Notice also the suffixes, both on the version element of the redistribution package and in the dependencies for the HR7 International and HR7 Germany packages. These allow our version numbers to mirror those of the original packages, and still update the packages if we find errors. For packages like the ICD-10-WHO, which we generate ourselves, the version schemes track the latest update of the respective package's content. And one last thing, all our packages are namespaced with @MII-TermServ. Where this is something that is not encouraged by the FIA NPM standard, this makes it very clear that we are responsible for these packages and also works well with established tooling so that the packages in our namespace can be downloaded from our own registry, which I'll explain later. We enforce a clear separation of concerns with this strategy. Put bluntly, the MRI, HR7 Germany or other organizations have no responsibility for making resources like ICD-10-GM or ICD-10-WHO available in their packages. This was previously the case, for example, in the modules Diagnosis and Person. Alright, so we define our own packages, but they don't just need to be defined, they also need to be made available. For that, we use the facilities GitLab provides us. Using continuous integration pipelines, we build NPM packages from Git repos and push them to the NPM registry of our GitLab group. That way, whenever we push a new release, the package becomes automatically available, and what's really nice is that we can both use the standard NPM tooling and GitLab-specific APIs to consume this registry. All repos are public, so that the entire process is transparent by design, and other organizations can use the same process and tools to publish packages that we then upload to our server as well. To set up the Node Package Management or NPM tool, you need to set up a .npm-rc file, as shown in the registry, and then packages can be added with the normal npm install commands. Based on the namespace @MII-TermServ that we use for all packages, requests for this namespace will go to our registry. The package shown here is also quite interesting. That's a synthetic bill of materials package for the core dataset that has all current modules as direct dependencies. It doesn't contain any content itself, just the dependencies. If you install that BOM, you will also transitively pull in all dependencies of the CDS. Lastly, I want to introduce our work with the FHIR Canonical Resources Management Infrastructure Implementation Guide, or CRMI for short. This IG lays out requirements for the lifecycle and distribution mechanisms of knowledge artifacts, which includes profiles and terminological artifacts. The SU-TermServ provides terminological services, so we are mostly in the distribution phase, which then supports implementation of the FHIR implementation guides, and we have a minor role in authoring as well. In terms of packaging, CRMI proposes the distribution using NPM packages or FHIR bundles. For distribution, the NPM registry mechanism is supported, and there's also a very interesting part that defines a syndication feed format. Syndication refers to making resources from upstream sources, like our server, available to other clients. You may be familiar with the flavor of syndication implemented by OntoServer. As we also use OntoServer as our terminology server, we, of course, also support OntoServer syndication. More information about syndication, as supported by OntoServer, is available in another video by my colleague Adnan on this channel. The flavor of syndication specified by the CRMI implementation guide is centered around making packages that are loaded transparent, so the content of the feed are NPM packages. We have implemented an open source tool that we use to generate the syndication feed. For that, it is plumbed into our upload tooling, so that it is always current. It is hosted alongside our terminology server. The feed is then available as an atom feed that lists all packages with their download links that we have currently loaded. But to be honest, that's not very exciting. What this tool then also allows us to do, however, very much is. Our CRMI implementation indexes all packages and resources in the packages, so that we can make the dependencies very transparent. Both for the declared dependencies of the packages as well as dependencies in the resources themselves, we use the recommendations in the implementation guide for our dependency tracing routines. As I record this in early 2025, the dependency graph is only available on the package level, but we are currently working on bringing this to the resource level as well. And another very exciting work that we have planned is working on reducing the load on our clients. Currently, we have about 9,000 resources indexed as transitive dependencies of the MRI's core dataset packages and other source packages. However, since our dependency resolution currently works on the package level, we know that a large number of resources from, for example, the core standard, the HL7 Terminology Authority, or the DICOM value sets are never referenced anywhere in dependent packages. By taking this very large resource graph and then essentially shaking it based on the resources we know we are interested in, we can reduce the set of resources to something more manageable, which could be very interesting to the data integration centers. And the standard defines a number of FHIR operations that we are looking to implement. Using the $package operation, the requirements of a given resource can be packaged in a FHIR bundle resource. Using $data requirements, the dependencies can be made transparent using the library resource that is also quite central in CRMI. There are other operations defined by CRMI that we plan to implement as well. Thank you very much for watching this presentation about our NPM infrastructure. If you have any questions or comments about this, please reach out to us. This slide deck is also available on our website.